So we'll do chemistry today. Question 92 is shortest wavelength in the Lyman series. So Lyman series is where n equals to 1. So if n equals to 1, then if we and the shortest wavelength, so n2 will be infinite because shortest wavelength may n2 is always infinite. So then the formula will be, if we just substitute the values in the formula, it will be 1 by lambda would be 1 by lambda would be RH, and we need to substitute n1 and n2, and the value of RH is given, and 1 by n1 square will be 1. So 1 by lambda would be RH. So RH would be the inverse of lambda would be inverse of RH, which would be, if we calculate 1 by 109,678 is 911.7 angstrom. So that would be the first one. Then question 93 is 600-volt mercury lamp emits monochromatic radiation of 331.3 nanometer. How many photons would be emitted per second? Okay. So there's formula for that also, which is E equals to hc by lambda. So if we just substitute here with E would be 600 and N would be number of photons which we need to find. H would be 6.62. C would be the speed of light, which is 3 into 10 raised to 8 by lambda, which is 331.3. So we just need to substitute the values here also. E equals to N H C by lambda. And we need to find the N here. So we need to just substitute the values, and when we'll do it, it would be 1 into 10 raised to 21 photons per second. Question 94 is, which is false? So HCl has one sigma bond. Yes, sigma bond is the single bond. So HCl has one sigma bond in its structure. That's true. Acetylene molecule has 3 pi bonds and 3 sigma bonds. That's false. 2 pi bonds are present here. Ethylene has 5 sigma and 1 pi, that's true, and water has 2 sigma and 2 lone pairs. So all of these are structure molecules. If you will make the structure of acetylene, that is C111C with H and H, you will understand there is only 2 pi bonds, not 3. So that would be the false one. N2 and O2 are converted to monopositive, N2 plus and O2 plus, which is incorrect. So you need to know the molecular orbital theory here. You need to know how to form the structures, which shells would get filled when N2 and O2 are converted. So N2, there are 5 valence electrons, and N2 plus the valence electrons would decrease. So it would be paramagnetic, not diamagnetic. If you draw on the structure of N2 plus, the number of shells which would be filled would be paramagnetic. So this is wrong. And O2, and there's also a formula of bond order. So bond order are number of electrons which are going in the bonding shell minus the number of electrons which are going in the anti-bonding shell upon 2. So that way also, if we look, the N2 will become paramagnetic. So this is incorrect. The first one is incorrect here. Intramolecular hydrogen bonding. This is inorganic question. You need to know it from the book. You need to know the structures, and you need to know that there will be intra and intermolecular, 2 types of hydrogen bonding are there. So in NCERT, there are several examples given of the molecules which are intramolecular and the ones which are intermolecular. So here it's O-nitrophenol that has intramolecular hydrogen bonding. So within the molecule, there will be hydrogen bonding, and in other 3, there will be intermolecular, means between the molecules, not within the molecule. So O-nitrophenol is the correct one. 56 gram of nitrogen and 96 gram of oxygen are mixed isothermally, and the total pressure is 10 atm. The partial pressure of oxygen and nitrogen. Okay, so there is a law that the partial pressure of a substance equals to the mole fraction into the total pressure. So the partial pressure we need to find out. The mole fraction, 56 gram of nitrogen, that is equals to 2 moles, and 96 gram of oxygen, that equals to 3 moles. So 2 by, yeah, so the mole fraction would be 2 by 5, 2 upon 2 plus 3, 2 moles of nitrogen and 3 moles of oxygen, into total pressure is 10, which is given. So yeah, so the pressure of nitrogen would be 4, which is here, and you can find the pressure of oxygen, that would be 6. So here the enthalpies are given. So first you need to know the equation of this, then you can solve it. So H2 plus O2, so you need to know the structure of H2O2 and H2O2 to solve it. So H2 has a single bond obviously between it. H has a single bond. O has a double bond in it. So this is structure of H. This is structure of H2O2, which has all the single bonds in it again. And O2 has a double bond in it. So you need to calculate the standard enthalpy change, which is the total energy in making the product minus the total energy in making the reactants. So all the values are given. So O and H have the value of OH bond is 464. So you need to multiply it twice because there are two 464 OH bonds. So 2 into 464 minus HH bond is 438 and O double bond O bond is 498. So that way, if you do, you'll get to know. You just need to calculate it. You need to make a structure and then you need to calculate it. And if you do it, you'll end up getting 130. If I'm not wrong, I had calculated it. I'm not sure. But you just need to calculate it now and it would be done. Okay, how many time in hours would be taken to distribute 1 Avogadro number of wheat grains in 10 raised to 23, 10 raised to 20 grains? So the Avogadro number is 6.02 into 10 raised to 23. And you need to find time taken to distribute 10 raised to 20 grains. 10 raised to 20 grains are distributed in 1 second. And you need to find out how much time is required to distribute 6.02 into 10 raised to 23 grains. So you just need to cross multiply, simple maths. So 6.02 into 10 raised to 23 upon 10 raised to 20. So you'll just get an answer and you need to find it in hours. So you just don't confuse yourself. You need to find it in hours, and if you calculate it, you'll get 1.67.3. You just need to do the math here. Okay. So we have a reaction and we need to find the K3 for the reaction. So the first one, 2PQ gives P2 plus Q2. So if we just so if we just reverse the first one equation, then it would be P2 plus Q2 would give 2PQ, right? And we need to inverse the K1, because when we reverse the reaction, we need to inverse the K1 as per the rules to make it go with the equation. So K1 would now be 1 by 2.5 into 10 raised to 5. And the second one is, we need to know that what we need in the final equation. Why did I reverse this equation? Because I need P2 and Q2 on the left side, not the right side. So I reversed it. And now we need half P2. So we'll divide this equation by half. So this K2 will also be divided by no. When we divide the equation by half, the equilibrium constant will have to be square rooted. These are the rules in the NCERT which you should know. So we'll have to square root this thing. Yeah. So when you solve this, you'll get 0.002. And for the second equation, we just need to now add the second equation to this equation, this one, the one with the half thing, where we did it half. You just need to add that to this equation and the second equation. And when you do that, if you can see, when we add this one and this one, this one, this equation and this one will, everything else will get cut off, and you'll just be left with the equation we need in the final thing. And if you calculate the K1 and K2 with it, the answer would be 1 into 10 raised to 5. Yeah, this one. So you just need to do the maths here. You need to know how to convert the equations to get the final equation. That's the only rule. And when you reverse the equation, or when you divide it into the half, what is the rule of changing the equilibrium constant, that you need to be clear with. Okay, so amount of solute that must be added to 180 gram of water to make the water pressure, vapor pressure of water lowered by 10%, not to 10%. This is a very common mistake. You need to know how much is the pressure going to be. So it is lowered by 10%. So 90% of the previous pressure. So the molar mass is 180. And here also we have a formula. The pressure of the pressure of the solvent minus the pressure of the solute upon the pressure of the solvent gives the mole fraction of the solute. So if we just apply it, this is the pressure of the solute. Sorry, this is the pressure of the solvent minus this is the pressure of the solute upon the pressure of the solvent will give the mole fraction. This is a simple formula from the NCERT, no rocket science here. So if we just substitute the values here, the original pressure is 100. The new pressure would be 90, not 10. We need to just lower it by 10%. So it would be 90 upon the original pressure is again 100. And we need to find the amount. So amount means if we find the moles, we can find the amount, right? So if you solve this equation, X would come to be 60. The molar mass is already given. You just need to find the numerator. And when you solve it, the X would come to be 60 grams. Okay, this is an easy one. Here you just need to find the molarity of the new solution. So we need no formula M1V1 equals to M2V2, where M1 and V1 are the molarity and the volume of the original solution, and M2 and V2 are the molarity and the volume of the new solution. So if we just, so here 200, the initial volume is 500, the initial molarity is 0.2. And we need to find the new molarity, and the new volume would be 700 because 200 ml is added. So total volume becomes 500 plus 200, so it will be 700. You need to find the new molarity, which is M. So if you just solve it now, you'll get the answer as 0.1428, which can act as both oxidizing and reducing agent. So you need to know here that the elements which are in the highest or the lowest oxidation state would not act as both oxidizing and the reducing agents, right? So if we see here, the oxidation state of Mn would be +7. So it is in the maximum oxidation state. Here NO3 would also be in the maximum oxidation state, that is +5. Here the chlorine is also in the maximum oxidation state, that is +7. But here the chlorine is in +1 state. So the range of chlorine is -1 to +7. So it can even act as a oxidizing or the reducing agent. So here the answer is chlorine. The only takeaway from this one is if the agent, if the metals are present in the oxidation or the in the highest possible oxidation state, then they won't act as both the agents. Otherwise, they would. Okay. So this is a inorganic question again. So you need to know the theory here. There is no logic. So the formula of the salt is this. So this is correct. The structure of FeCO5 whole FeCO whole 5 is trigonal bipyramidal. It is given in NCERT. It has structure something like Fe is here in the center, and there are 5 CO molecules with it, like this. And the structure turns out to be trigonal bipyramidal, so that is also correct. Here, the incorrect one is this one. It is not diamagnetic. If you fill out the valence electrons of chromium in the order of sp, then sigma, sp, and the whole all the shells, you will see that there are unpaired electrons left. So when there are unpaired electrons, it is a paramagnetic structure, not a diamagnetic one. So the incorrect one would be this. Okay, highest boiling point. So there's a rule that if the more the number of molecules are in a solution, the more would be the boiling point. Just the more the number of molecules or more the number of ions. So in FeCl3, there are 4 ions, 3 Cl and 1 Fe ion. So 4 here. In BaCl2, there are 3 ions. NaCl, there are 2 ions, and urea cannot be ionized. So the maximum number of ions are in FeCl3. So the answer would be this one. Okay. So 1 Faraday of electricity is passed through all 3 of these: aluminium, copper, and sodium. And you need to know the mole ratio. So mole ratio would be the number of what is the valency of the substance that would determine the number of electrons it displaces. So aluminium would displace 3 electrons because it has the valency of 3. Copper would displace 2 electrons. And Na, sodium, would displace 1 electron, right? So by 1 mole of 1 Faraday of electricity, 3 moles of aluminium, 2 moles of copper, and 1 mole of this thing. So this 1 Faraday would give 3 moles of this, 2 moles of this, and 1 mole of this. So if we take a simple ratio of it, then it would turn out to be 3 by 6 by 2. Okay, so these are the ionization enthalpies and the electron gain enthalpy. This type of question is given in NCERT and exercise. This is the same type of question. So if you have solved it, you would know. So we need to find the most reactive metal and the least reactive non-metal out of the following. So the most reactive metal would be one whose ionization energy would be the least. So it can react most easily. So out of all these, 419 is the least. So second element would have the most reactive metal because of its least ionization energy, and the least reactive. So the one with the positive electron gain enthalpy would be the one which will not react. It will repel from reacting with the other substances or other elements. It will not take or give electrons. So the positive electron gain enthalpy is metal. Non-metal is the one which is the least reactive, which is metal 5 here. So the most reactive would be 2, and the least reactive would be 5. So that is option 2. Conclusion similar to those by Charles Darwin. This is, I think, a bio question here. I don't know. I'm not sure about this. It would be mentioned in NCERT, I'm supposing. I'm not sure about this. So we'll mark it for review. Okay, this is again an inorganic question. You need to read the colors produced and the metals which produce color, metals which do not produce color. It's given very nicely in NCERT. There's no solution, no logic there. So this is the rubidium is the correct one. I know it, but you need to read it to find out. Okay. Dibasic acid. Dibasic acid is basically an acid which has 2 OH bonds in it. So you need to know the structure of all these oxo acids to know which one is a dibasic acid. All these structures are given in NCERT. So out of all these, H3PO3 would be the one which will have 2 OH bonds. So the number of OH bond gives the valence of the acid it is. So dibasic acid has 2 OH bonds. So here H3PO3 is the answer. You need to know the structures of these. So you need to draw and find out. And some like HCPO3 is divacic acid, it is asked many times, so it's better if you just know it, if you learn it, it would be better in exams, it would save time. Okay. Reduction with hydrogen peroxide. So out of all these metals, no, all these elements which would undergo reduction in an alkaline medium, so you need to know the equation with all the elements. So we start with Mn and we need to do it with H2O2. So the product would be, the products you have to know by the reactions given in the NCRT, or yeah, it would be these reactions are given in NCRT, so you need to know the products that way, which products would be formed. So here, no, H2O2, so H2O would be formed here. So if we see the oxidation state here is +2, which is given in the question, and here it would be +4. So it's undergoing, Mn is undergoing oxidation, not reduction. Same way, if we see in all these Fe2 plus and PBS, it would also be undergoing oxidation, not reduction, but only HOCl would undergo reduction in presence of H2O2. So likewise, you need to write the equations and then you can figure out if it's undergoing reduction or oxidation. And for that, it's very important that you know the structures and the reactions of all the metals, at least the ones given in NCERT. Okay, we need to find out which one is true. So this complex, if we ionize it, it will give ions. So it is an electrolyte, not a non-electrolyte. It will give out ions. So first one is wrong. So A and B are eliminated. Similarly, third one is also wrong because the complex will conduct current. If the complex give ions, then it does conduct a current. So third one is also wrong. So if we just see the options, you will understand that 2 and 4 are, this is the only one which is correct by the elimination process, but you read the other options, the magnet of charge on each complex ion. So if you know this complex, if you're familiar with the complex, you would know the structures. Here NH3 would have no charge and CN has a charge of -1. So 6 CN, so CN -6. So if you solve it that way, you will know the magnitude of charge of ions is +3 and +3 here, that way. So this is correct. The complex will exhibit coordination isomerism. This is given very nicely in NCERT, the coordination isomerism. So yes, the magnitude of charge on each complex ion is 1, that is wrong. So if you see it, because it is 3, we just discussed it. So 2 and 4 would be the correct one. And yeah, we have take that. So that is correct. Okay, halogens which exist in all these states, but halogen which exists only in -1 state. This is also an inorganic question. Fluorine is the halogen which exists only in the -1 state because of its the placement in the periodic table. It is very negative. It won't give its own -1 ion. It will only take, so it will just exist in -1 state. This is again a theory question, and inorganic question. You need to know it. Okay, so you need to just balance out this chemical reaction. So the trick here is when you have MCQs with you, just start with a random option and then you need to check out that if you place an ABCD in this reaction, does it get fulfilled or not? Does the reaction get balanced or not? The trick is this only in MCQ. If you are writing a theory paper, then you need to do that A is equal to you need to do trial and error then, but in MCQs you have this 4 options, so you need to try out one by one and you will know. And the more questions you practice, the more you'll just look at the equation and come to know that which one is it. So here it is, yeah, here it is 5633. By the balancing, by the trial and error method only. If you look at it, if we keep all these numbers here, it will get balanced. So that's the way you do it in MCQs. Okay, petrochemical industry, alcohols that are directly converted to gasoline when heated. This is also an theory question, an organic question. You need to know it. The catalysts which are used in certain reactions are given in NCERT. So that ones you need to remember. So ZSM5 is the one here, but you need to read the NCERT to know it. Okay, all carbon atoms that are sp2 hybridized. So sp2 means sp2 is a state in which there are 2 sigma and 1 pi bond. sp3 means all sigma bonds. Sp means 2 pi and 1 sigma. And sp2 is 2 sigma and 1 pi. So if you count here, if all the atoms are in sp2 or not. So here if you see, this carbon has 1 pi in it. So this is in sp2, but this carbon has 2 pi's in it. So it is in sp state. So this option is eliminated. 1,3-butadiene, the structure of 1,3-butadiene is butadienes means 4 carbons and 1,3. So 1 and 3 would have a double bond in it. So 1. If you look at the structure here, all the carbons are in sp2 state. All the carbons would have one double bond with it. This carbon and this carbon shares this double bond. This and this has this double bond. So this one is the correct one. Then we'll look at the other options. And this also, this carbon is having 2 pi bonds. This carbon also has 2 pi bonds. So this is wrong. And cyclohexane, all the carbons would be in sp3 state because it is a not it is a cyclic structure with no double bonds. So second one would be the correct one here. Lasignier's test. The sodium fusion extract is first boiled in nitric acid. This is a favorite question of NEET. I don't know why, but it is asked in many times in the previous years. Better you know it, better you just mug it up. The answer is to decompose Na2S and NaCN. This is done. Concentrated nitric acid is used. There's no logic or explanation here, but the proper method of how it is done and the reactions involved are given very nicely in NCERT. And for the purpose of NEET, it's better if you just remember it, mug it up, that this is the reason why this is done. Okay, ring chain isomers. Isomers are basically the compounds, the structures in which the molecular formula is the same, but the structure changes. And ring form means one form should be the ring structure. So all here, if we see the number of hydrogen here are 8, number of carbon are 4, and 2 OH are there. 2 OH are there. But if you count the number of hydrogen here in this cyclic structure, it won't be 8. 2 hydrogens here, that's 2, plus here 2, 4, 5 and 6. There will be only 6 hydrogens. So this is incorrect. Similarly, if you count the number of hydrogen in these structures, you will understand that they are not the same. It is only same in this structure. If you count here, 4, 5 hydrogen and plus OH. And if you count it here, 2 here, 2 here, and 1 here. 5 hydrogen and 1 OH. So in isomers, you just need to first check that the number of carbon and the hydrogen in both the structures are same. If you check only in the third option, it is same here, and other all it differs. So third one is the correct one here. Okay, we again need to mark the correct statements. Manganese exhibits +7 oxidation state. That's correct. It has the maximum value of +7. So 1 is correct. Zinc forms colored ions. This is wrong. Zinc is a paired molecule. So the ions or the molecules which are paired would not have colored ions. Only the unpaired electrons would react with light to form the colored wavelength. But because it's paired, so it won't have colored ions. So 2 is false. So if you look at the option, 1 and A and B gets eliminated. Only 3 and 4 is left. So COFe6 3 minus is diamagnetic. Again, you need to fill out the electrons in the various shells according to the rule 1s square, 2s square. The whole rule is there. So if you fill it out, you will understand that no, it is a paramagnetic structure. It would have unpaired electrons in it. So it would be paramagnetic. Se forms +4 oxidation state. This is also incorrect. It won't form a +4 state. But Zn exhibits only +2 oxidation. Yes, this is correct because it would have 2 the outermost shell of Zn would have 2 electrons, and it would give out that 2 to become a stable structure. So it would exhibit only +2 oxidation state. So 1 and 5 are correct. That's option 4. Okay, so the ratio of the ionization is given, and we need to find out the ratio of the equilibrium constant of both the acids. So there is a rule that the ratio of ionization, it's more like a formula than a rule. The ratio of ionization of two acids, their equilibrium constant would be this root of it. So this is the formula. The root of the ratio of the ionization would be equal to this. So, no, sorry, I wrote it wrong. The root of the ionization, the root would come in the equilibrium side, not this side. So this is what it is. So the root of this would be this. So if you solve it, 4 by 9 would be the root of Ka by Kb. So you just need to square this up. So if you square it up, you get Ka and Kb. So the answer would be 16 by 81. This is a formula, and it's better if you know it, because in many questions only the ratio of ionization and the equilibrium constant is asked. The whole formula is not asked. So if you know the relation, that would save time again. Okay, the IUPAC name of this compound. So there are certain rules of IUPAC naming. The first one is the longest carbon chain would get the for the primary chain and number. So the longest carbon chain should be taken in consideration. So if we look at over here, if we count it from here, so two carbons here, so 2, 3, 4, 5, 6, 7, 8, 9, and 2 CH3 would be attached this way. So we can count 1, so 10. So that is the longest chain. If we can see in the option, decadiene is the longest one, right? So 1 or 4 should be the answer. And then the second rule is that the double bond should come in the position where the carbon number is least. So if we count it from here, the double bond would come in 4th and the 6th position. And if we count it from here, then it would come in 5th and 7th position. Right, so 4 and 6 is lesser than 5th and 7th. So the option would be number 4. You need to know the rules. The priority in the rules, when to consider triple bond, when to consider double bond, when to consider the longest chain. The longest chain rule is the first one. It has the most priority. So the longest number of carbon chain you need to always consider. That way, 2 or 3 options would automatically get eliminated. So it would be easier for you. So 22 is the number of carbons that are linearly arranged. So you need to know the carbons which are sp state are the ones which are linearly arranged. This geometry you should know, and that the ones in sp would be linearly arranged. It is given in NCERT very nicely. sp3 would be arranged in a different shape, sp2 in different shape, and sp would be linearly arranged. So you need to know how many carbons are in sp state. sp state means 2 double bond, 2 pi bonds and 2 pi bonds should be present in a carbon atom. So here if you see, this is a sp3 carbon, there are no double bonds attached. If you see here, 2 carbons are in sp state, two bonds are present, 2 double bonds are there, right? So this is the sp state carbon. This is similarly a sp state carbon. And if you see here, only 1 double bond is there. So 1 pi bond is there. So this is a sp2 state carbon. These both are sp2 states. So 2 carbons are in sp state. So 2 carbons would be arranged linear. So third one is the correct option. Chlorination of benzene in the presence of a halogen carrier. So chlorination of benzene is basically adding chlorine to a benzene ring. And here it's mentioned it is in the presence of a halogen carrier. So HCl or anything can be used. So benzene plus HCl, and you need to add this Cl to the ring. So obviously, because this is an aromatic structure, so all of these are aromatic reactions, and then the halogen would enter in the form of a electrophile, not a neutrophile. Because to stabilize the benzene ring, electrophilic substitution is preferred more. So Cl here would enter here as an electrophile. So this would be aromatic electrophilic substitution reaction. And substitution because with the adding of a Cl here, a hydrogen atom would leave to maintain the structure of the benzene ring. So the chlorine won't be added, it would be substituted for a hydrogen atom. So it is an electrophilic substitution. This question is repeated. As we said, 4 ions are present in the solution. So the boiling point would be the highest. The more the number of ions, the higher the boiling point. Aryl halides do not undergo nucleophilic substitution reaction. Why they do not undergo? So this is the aryl halide here. Aryl halide is nothing but a structure where there is a ring structure with a halide, fluorine, chlorine, bromine attached to it. This is a aryl halide. So why do not they undergo nucleophilic substitution reaction? The first reason is because if they undergo substitution reaction, the double bond character of the benzene ring would be lost. And the benzene does not want to do it because it is more stable in this double bond character. So that's the primary reason they do not undergo nucleophilic substitution. So partial double bond character between carbon, because of the partial double bond character between carbon and halogen. This is correct. This is the major reason. And the approach of nucleophile is retarded because of its the losing of stability. The nucleophile will be retarded. So this is also correct option. Carbon carrying halogen atom is not sp3 hybridized. Here all the atoms are sp2 hybridized because all the carbon atoms have a double bond in them. So it is sp2 hybridized. So this is incorrect. The substrate molecule is destabilized. It is stabilized due to resonance, not destabilized. So this is also incorrect. So 1 and 4 are correct. So option 3 is the correct one here. The compressibility factor of real gas at high pressure. So there is a real gas equation, which you probably know, NCERT equation, which is P plus A upon V square, where V is the volume, into V minus V gives nRT, where N are the number of moles. This will give nRT. So we need to know the factor at high pressure. So at high pressure, A by V square can be neglected. So A by V square becomes 1. It becomes 0. So we can neglect it. So if we solve this equation, and n is 1 here because it's not mentioned number of moles, so we can take it as 1. So P plus P minus V equals to RT. And the compressibility factor is Z, which is equal to PV by RT. This is the compressibility factor. This formula, you need to know what is the formula of compressibility factor. PV by RT is the compressibility factor. So if you solve this equation, P plus V minus V equals to RT, then you would get Z equals to 1 plus PV by RT. So you need to solve this real gas equation to get it. Amines that cannot be prepared by Gabriel thalamide synthesis. So the any structures which has any aryl structures cannot be prepared by this method because of the structure of the ring structures are destabilized by Gabriel thalamide method. So anything which is ring cannot be prepared by it. Aromatic substances cannot be prepared by Gabriel thalamide method. This is given in NCERT. So out of all this, only aniline is a aromatic substance. Benzylamine, isobutylamine, tertiary butylamine, all are straight line structures. So they can be prepared. Aniline is an aromatic structure. So it won't be prepared by Gabriel thalamide method. This is again, I think, a bio question. Uracil is not present in DNA. All the 3 bases are present. Okay. You need to know Jones agent. Jones agent is something which oxidizes the OH. Not OH, but anything it oxidizes. Jones agent is used for oxidation. So here only OH is the one which can get oxidized, right? So out of all three, from alcohol, a ketone would be produced. So if we see in option 2, a ketone is produced. In option 1, the double bond is lost, which does not get lost by Jones region. And option 3, also double bond is lost, but OH is remaining. And here acid is produced, but only it oxidized to only one step because it's a weak oxidation region. So only a ketone would be produced. So B is the correct option here. Lactose. This is also a theory. It is made of glucose plus galactose. Both are beta. This is given very nicely in inorganic. All this chapter of inorganic chemistry are very important. There are direct questions out of it, and similar questions are there. So if you just do the previous year papers, you will know, what to not know, what to mug up. So all these lactose, fructose, you need to know with the structures which is involved, which isomers are used. This is again a inorganic cetyl trimethyl ammonium bromide is a cationic detergent because it has a positive charge in it. The structure is given in NCERT. So this also you need to just know. Okay, this is temperature. So there is a concept that forward reactions can always be favored if the substrate is added more or if the product is removed. So if the reaction, if the reactant is added more or the product is removed, then the reaction would be favored in the forward direction. And the other one is at anything added at constant volume would not make a change, because if you are adding it at constant volume, you are not increasing the quantity of the reactant or the product. So anything added at constant volume would not move the reaction forward or backward. So this and this gets eliminated. If you introduce an inert gas at constant pressure, then the forward reaction would be um, favored. So here option 3 is the correct one. Okay, the increasing order of pKb. So pKb is basically acidity. It is pKb means 1 upon basicity. 1 upon basicity is acidity. So the acidity you need to find out of all these three structures. So if you see the number of more the nitrogen bonding, more the nitrogen resonance, double bond resonance is there in a structure, more is the basicity. So less is the pKb. pKb is 1 upon basicity. This is 1 upon basicity, right? So basicity increases by the revolving resonance structure. So here most revolving resonance structure would be in second structure, because the double bond can go to this ring, it can travel to this ring also. So 2 will have the maximum basicity, means the least pKb. So here the least pKb is this or this. So 1 or 3 would be the correct one. In a first structure, there is one double bond. So the double bond can resonate only once. And here there is no double bond. So it will have the least basicity, means the most pKb. So 3 would have the most, then 1, and then 2. That's option 1. So you need to determine the basicity, the pKb, by the number of revolving structures of the double bond. And that way, if you know the relationship between pKb, acidity, basicity, then it would be easier. This is again an inorganic question, the purest form of commercial iron. It is given very nicely in NCERT. It's the wrought iron. Need to memorize it. Okay. The electron gain enthalpy of fluorine, chlorine, bromine, iodine. There is an exception here. It should increase down the enthalpy should increase down the group, but the enthalpy of chlorine is more than fluorine because of the structures of the ions that way. So chlorine is more than fluorine. So the option 2 would be the correct one. Fluorine would have the least enthalpy, and it would increase it down the group then symmetrically. Then the theory that can completely explain the nature of bonding in this complex. So molecular orbital theory explains most of the bonding structures. So if you're not sure, always go with MOT. And if you know the theory well of NCERT of inorganic, then well and good, then you will know it is a molecular crystal field is used for the wavelengths, and these are not honors theory. I don't think is given in NCERT. And valence bond theory is for the valence electrons. So here MOT is there, and mostly all the structures are described by MOT only. Okay. So here we need to find out the bond order between C and O, Cl and O. First, we need to make out X and Y. Chlorine reacts with NaOH. So we need to form an equation here to know what is X and Y, and then we can know. So chlorine here reacts with NaOH and gives X and Y. And here it's given that X is a white precipitate. So probably it's a salt. Gives a white precipitate with silver nitrate. So it's probably a salt, and we need to find the bond order of Y here. So NaCl plus NaOH would give NaCl, which is a salt, plus, so NaCl would be X here, and Y would be NaClO3. This is a reaction, you need to know it from NCERT, an organic reaction. So here NaClO3 is the Y we are talking about, and we need to find out the bond order between Cl and O atoms in Y. So here you need to know the structure of NaClO3 for that, and also there is a formula of total number of bonds, total bonds upon the number of resonating structures. That will give the bond order between any two elements or atoms. So here total number of bonds would be 5 between NaClO3 if you know the structure, and resonating structures would be 3. Electrons would be able to resonate in 3 different structures. So if you know it, if you know the formula, you will get 5 by 3 here for the bond order, and 5 by 3 is approximately 1.67. So answer is 1.67. That's all. This is physics now. So chemistry is done. So the major takeaway is that if you know the NCERT inorganic part, you will be able to get marks there. And for you also need to know the reactions of inorganic chemistry for many equations. If you know the structures and the reactions, your inorganic is solved. And organic is very direct from NCERT. If you know the concepts, you will be able to solve it. Yeah, that's all.